In the last few lectures, we had learned a lot about lists. We had learned how to access elements, how to append to them, how to extend them, how to take slices, and last but not the least, how to use list comprehension to produce complicated big lists out of iterables. Now, in this particular lecture, I'm going to tell you everything that is there to know about lists. Now that is a bit of a stretch. After all, lists are very powerful, they are very important, and there's a lot to learn about them. But the overstatement I made just now is in a way justified. Essentially, I'm going to tell you all that Python's documentation tells you about lists. More importantly, I'm going to show you how to find it out for yourself. Now, as I keep on saying to students who want to learn computing, especially those who learn Python, when they come to me with a problem, my usual advice is to ask them to search. Just go on the net, search Google, and almost certainly you're going to get your answer. But the important thing is you don't even have to have a net connection for that. If you have a working Python connection, Python's own documentation should tell you a lot about whatever you want to know. Of course, the documentation has to be a bit terse, and so it's somewhat cryptic and might look a bit daunting at first sight. So what I will do today is I will help you to navigate through Python's documentation about lists, try to understand what it says and how you could use it to learn more about not just about lists but about any other Pythonic construct that you want to know about. So to begin with, let's start with a list which I have to work with. So let's say I'm creating a list and storing it in a variable called li, and I'm doing it by hand. I'm just going to put in a few random kind of things in the list. Sorry, that should be a comma. And that's it. Let's say we have already seen how to access elements from this list, how to take slices, how to append to this list, how to extend this list, and so on. What else can I do with this list? Well, for that we need to know what kind of methods are there. What are the methods that we can use with lists? And where to find out? The answer is help. Sorry. Now that we have defined the list, let's ask for help. There are two ways of doing this. I can either say help. There's a function call, so it needs an argument. I could give help list, or if I have created an instance of a list object, which I have done right now. Remember, list is just a blueprint, a design. It's a design for what kind of objects you can put in this, or what you can make list do. The li that you have up there, we have just created, is basically an instance, a particular single copy which has those list-like attributes, so to speak. So in a way, list is like a blueprint, and li here is like a building which you build using that blueprint. So I could just ask for help list, or I could also say help li. I will get the same result in both cases. Now, at the top of it, it says something which list is an iterable and certain things which make no sense right now, and there's a lots and lots of stuff here, right? Now at the beginning you see there are lots of methods which have been defined and described. These are rather difficult to understand at this stage, but you can also see they have a crazy kind of name. The name starts with 2 underscores. This big fat line in front, this long line, is really fat simply because it's not one character, it's 2 characters, 2 underscores, and there are 2 underscores at the end. The methods which start with 2 underscores and end with 2 underscores are actually very, very important. And later on, when we learn about object-oriented programming, we are going to learn a lot more about such methods and how to use them in writing our own objects, perhaps. However, for the time being, these are a bit too advanced for where we are right now, so we are going to skip right through them. So there are lots and lots of such methods, and once the list of such methods end, now you have ordinarily named methods. Append, our old friend, is here, but that's not the only one. You can see right next to it is clear, then copy, then count, then extend, which we know already, index, insert, pop, remove, reverse, and sort. Well, that's it. I'm not really reading the help a lot in detail right now, because we are going to take turns and go through each one of these commands, at least the newer ones, and take a look at what the help says for them specifically. So these are the methods that a list object has, and we are going to describe these methods one by one, except for, of course, for append and extend, which we have already seen before. Now, let me also tell you that lists are, well, rather thin in the quote-unquote list of methods that they have. Other kinds of Pythonic objects may have many more methods tied to them, but in comparison, lists are rather less complex, so to say. They don't have that many methods. And do we have to understand all of these methods thoroughly in order to program in Python? The answer is no. But it's good to be aware that such methods exist, so that whenever you need them, you can go back to help and ask for that method and understand what the method does. Now, one good thing about using the interpreter is that such help is always right at hand. You can ask for help whenever you need it. And that actually is a huge advantage when you're trying to learn something. So now, let's go through these things one by one. Let's start with append. You already know what it is, but let's see what the help says here ties with whatever I know already about append. Notice, append is a method, and a method comes with arguments, so you have the set of arguments to be given to method given here. To append is listed here. It looks like there are 3 arguments. But wait, in the last video we discussed that append takes only 1 argument. How come here we see 3 of them? Self, object, and a slash. Well, the first one, self, is there because it's there to remind you that a list method, or in fact any method tied to an object, needs to have an object to act upon. So when I'm going to call append on li, I'm going to call it as li.append, and self refers to none other than the li in that case. If I had some other list, say call it abc, and I wanted to append something to it, I would use abc.append, and the self in this argument list will refer to abc. So in the actual argument list that you use when you call the append method, you will not write self. Self is automatically assumed to be the object on which append is acting, or the object to which append is tied to. In our application, it will be the list li. Then comes the second argument, which is called an object here. Could be any kind of thing. Append object to the end of the list, which is sort of commensurate with whatever we had learned so far. Right? You call the append method on a list, say li, by saying li.append, then put a round bracket, then put in whatever you want to append inside the round bracket, and that gets added to the list as its last element. But then what is the slash doing here? Now let me warn you that some of you who are programming along with this will not see the slash in your help. That is because this is a rather recent addition to the Python documentation style. It's really not an argument at all. It's simply there to tell you that this is where the list of positional arguments end. If you think back about the way we defined functions earlier, function arguments were defined via position. So if you said define a function f with a function f of x comma y, and then you called it with f of 3 comma 4, x became 3, y became 4. But you could also use keyword arguments, where you could forget about the order in which the arguments occurred, just use the names of the variables to tell Python, okay, this particular value I am giving when I am calling the function goes into this particular argument, not in any other argument. Now that kind of named or keyword argument is very useful, but not all arguments can be used like that. From Python 3.8 onwards, the documentation clearly demarcates them. All the arguments that appear before the slash are positional. Arguments which appear after the slash are keyword arguments. They can be referred to by using the names. Now in this case, of course, there are only two things before the slash. One of them is self, which is nothing but the list whose append method you're talking about. So there's really only one argument, and that's positional. You can't say object equal to something while calling append. You will have to give the value of the argument in the first position. There's only one position to worry about here. Later on, if we go down the list a bit, so here, for example, in index, we will see what index does soon. But you have self, which again we don't have to supply. It's already there in the name of the list to which you are going to use, on which you're going to use an index. Then you have value, which goes in the first position. Then you have start, then you have stop. All these three are positional. That's indicated by the fact that slash comes after all the three. Remember 3, not 4, because self is, as I said, the name of the list itself. Okay, this should be clearer once we start talking about these methods one by one. Append, there is really nothing to talk about any longer. We already know what it does. So we will start with clear. And of course, I don't remember all these by heart, so I will have to perhaps look up the help several times during this video. But first, now we need to get out of the help before we can use these methods. And the way to get out of help is Q. So I hit the Q and I'm out of the help. Now I can use the various methods that we saw right now on the list li. So the very first one, clear. The name itself should make it obvious what it does. It's a method, so when you call it, whether you want an argument or not, you will have to use round brackets, and if you don't want an argument, keep the round brackets empty. Now of course what this does is clears the list, so let's try it and see. Of course it didn't tell you anything, but let's see what has happened to li. It has become an empty list. It's still a list, note, but it is a list with nothing in it. Okay, so that's a bit destructive. I need the list li to go further, so clearing it out completely is maybe not the best thing to do, but we have already done it. So let's create the list li again. Copy, that comes next in the list of methods which list has. But we will discuss copy later because there are certain other issues that goes with it. let's move on to the next one, count. Now by now my memory has completely failed me. I don't remember what count does. I can sort of guess, but let's check. So how do I check? I can go back and ask for help on list, entire list, or help on li. But I can also ask for help on li.count if that's the only thing we want. If you don't remember that there is a method called count, you have to of course go and look at the list for help for the whole thing. But if you remember that there is something called count but you're not sure exactly how it works, just look for help for li.count. And here it says help on built-in function count. Count value slash. Okay. So it says that this is a method of the built-ins.list instance. So it's a list instance that we are talking about. It's always available for you. So it's in built-ins. Remember, return number of occurrences of value. What happens if I use list.count? There's a slight difference here. Notice it says count self comma value slash. The slash, remember, just tells you that every argument before that is positional. Return number of occurrences of value. This much is common. But here you see it says self comma value as opposed to what we saw when you ask for li.count. It just said count value slash. So the self is missing from the argument list here. And that's not a surprise because when I said li.count, I've already asked for count to be used with the list li. Okay, so self has already been given in a sense. So this kind of thing you have to remember. The self essentially refers to the object to which the method is tied, and if you are looking for help of a particular instance of the object followed by the method name, Python will not give list self as an argument any longer, because when you're calling it, you're already asking for it, or you've already stated that this is for the instance li. Anyway, let's move away from these slightly technical issues, and now let's use it. Well, how do you use it? I would use it as the standard template. Name of the instance li comes first, then you have a dot, then you have count, the method, and the argument value. Say 8. How many times does 8 occur in the list? And the answer of course is 0. It doesn't appear there. How many times does 7 occur? The answer is 1. How many times does 9 occur? The answer of course is 0. There is no 9 in the list. This entry, the last one, is actually 9.1. So it's sort of straightforward. It just counts how many times a particular object occurs there. Particular value is there in the list. So count done. Extend is the one next which comes next in alphabetical order. That's the way in which the methods were listed. But extend we have already seen. So let's move on to index. So let's ask for help list.index and see what that tells us. So help on the method descriptor index. Self, of course, li itself, and I'm going to say li.index. Value start equal to 0, stop equal to some huge number, followed by the slash. So it says return first index of value. That is, it just finds out where this value occurs for the very first time, and then raises value error. So raises an exception, an error, when the value is not present. And what does start stop do? They are basically like, well, they're basically like slice indices. They tell you that instead of looking at the whole list, you will just slice it between start and stop and look for value in that slice. So let me just go back to the list li and see how this gets used. So li dot index 1. Remember, both start and stop have default values, so we don't have to give them. If we don't give them, they just take default values. So li dot index 1. I'm looking for the value 1 in li. Where is it? What is its index? And the answer is 0, because that, remember, is exactly the index for the very first entry in li. Counting, remember, starts from 0. So it's telling you that the index of 1 in li is 0. Now, in order to proceed further, let me change the list li a bit, simply because li has very few repetitions. It has no repetition, so every element in li occurs only once as it stands now, and that will make it difficult for me to demonstrate issues with now let's do something. Let's extend li by using li itself. That means, remember, extend works by taking its argument, which has to be an iterable, breaking it into pieces, and then adding it to the list one by one. So here, if I say li dot extend li, what happens essentially is the elements 1, 2.5, apple, 7, 9.1, which were there in the list li, they get broken up and they get added back to li one by one. So li now becomes a list which is twice as long as it was before, and these elements 1, 2.5, apple, 7, 9.1 have been added to the end of the original list. So now, if I ask for index of 1, again I get 0, because remember, index returns to me the position or the first occurrence of the value. But what if I wanted to find out this position? Now that's not the one which index is going to talk about, because by default it's going to look at the very first time 1 occurs. But remember the start and the stop arguments? What we can do is this. 1, then these are positional arguments. Remember, they have to be given in order. You can't just say start equal to something. It makes no sense to Python. Really, you can just say li dot index 1 comma the next one. Now you can just say 1. Start looking from index 1. Index 1, remember, is this one. So here you are saying start looking from index 1 and look at the entire list and find out where does the value 1 occur in the list. And here it says 5. Let's see whether that's right. 0, 1, 2, this is 3, 4 and 5. So 1, the second one, is at position 5, which you can find only by putting a start value which is bigger than where the original the first one was. Well, what happens if I put a stop value as well? Let's say I put in a stop value which is 1, 4. So what we are really doing here is something like this. Although we did not explicitly write a slice, we are actually asking Python to slice li 1 colon 4. The 1 is a start value, 4 is a stop value. And inside li 1 colon 4, look for the value 1. 1 colon 4, of course, is element number 1, element number 2, element number 3. Remember, the stop index in slice is very much like that in the range function. It does not get touched. So this is the sub list where you're looking for the value 1. And of course, there is no value 1. So what happens? If I do this, what I get is an exception. I get value error. It says 1 is not in the list. The value 1, the error, of course, is value error because it's an error in the value 1. The value 1 is not in the list. Of course, you can see that there are 2 1s in the list li, but remember you asked it not to look for the entire list, but in the slice 1 colon 4. And even though we know that there is a 1 at position index 5, even this will give me a value error for the simple reason that when I slice from 1 starting at 1 and ending at 5, the elements that go into the slice are li square bracket 1, li square bracket 2, li square bracket 3 and li square bracket 4. Li square bracket 5 is not touched. So again you get a value error. Of course, if I just said something like 6, which means I'm asking to start at 6, I again get a value error because there is no 1 after the start position of 6. If you just give the start, of course the stop is a huge number, which means you're sure to get the whole of the list starting from the start position. So this roughly is all about index. Then comes insert. So let's quickly look up. The help on insert. So it says, okay, 3 arguments, but once again only 2 really. Self is the name of the object that I keep on saying. Index object. So it says insert object before index. Before index, the word before here might be a bit confusing, but it's before whatever is sitting in that index location now. Of course, if something was sitting in index location 4 and you put some object before that, that object now gets index location 4, and what was in 4 gets pushed to index location 5. So it's easier to think about this way. Put the object at index location and push the rest of the stuff back. So this is something which gives you much more flexibility compared to append. Append also inserts objects to a list, but it can only do that at the end of the list. Insert does it anywhere in the list you want, you just have to specify where. So there are 2 arguments, index and object, and unless my memory is playing tricks with me, index goes first, object comes next. Let me just check again still. Yeah, it is index first, object next. So where you want to put it comes first. That has to be an integer, of course. What you want to put, any kind of object, comes after that. So list, not list, li, the specific list that we want, insert so I'm inserting the object for 50.1 before index 4. Before index 4 means if you look at the list which is up here, this is 0, 1, 2, 3 and 4. So my 50.1 is going to go in and sit before the 9.1 and hence become index 4 itself. The object at the value at index 4. So let's see what has happened. 1, 2.5 apple, 7, 50.1. So 0, 1, 2, 3, 4. It has been put before the object at position which used to be at index 4. Now it's index 5, of course. Everything else has been pushed back. Now, what happens if I try to put it as a 10? No problem, it just gets pushed it at position number 10. But what happens if I try to push it at index number 20, let's say? There is no index number 20. So this is where the simple thing that I said a while ago becomes wrong, right? It's really not put at index position, it's really put before index position. In this case, because there is no index number 20, it has to be put before that, it gets added to the end of the list. So it's really not trying to put it at index location given, but it's before index location, wherever possible. Not wherever possible. If that index location exists in your list, it's going to sit at that index location. If that index location is beyond the length of your list, it's going to sit at the end of the list. That's how insert works. So what else do we have? Okay, let me quickly take a peek at the list, help for the list itself, because I've forgotten what comes after this. So quickly scrolling through this whole set, we've gone to index, insert, top, remove, reverse, sort. So 4 things to go. Okay. So help list.pop. I'm pretending that I don't remember what pop does. I actually do. But if I forget, I can always ask for help. And that is the most important lesson I want you to take away from this video. Not the specifics about this list. They are useful, but you can learn them anytime you want just by asking the help. What is important is you should never be afraid to ask for help, especially from the Python help system. Here it says, removes and returns item at index. Default last. Notice there are 2 arguments. The first, or really only one argument, which is an index, and it has a default value -1, which means if you just use pop without specifying the argument, it's going to assume the index is -1, and -1 index, of course, as you remember, is the last entry of your list. And it also says raises index error if list is empty or index is out of range. Okay, so let's see what this means. But what is critically important is this. It says remove and return. Okay, return means it's going to give you back something. When you call the method gives you something. I've already seen examples of methods which return stuff. Just to remind you, so li.count, say 1. It tells you 2 now, because of course there are now 2 ones in the list. This has not changed the list in any way. It has not done anything to the list. It has just given you back or returned to you the value 2. And because you did not assign the return value to any variable, so because you did not do something like this, there was nothing to catch the return value, and by default in such cases the return value comes out on the screen itself, so you can see exactly what is being returned. In this case you can't see what is being returned for the simple reason you're assigning the value which has been returned here to the variable n, but you can see what was returned by just looking at the value of n. Okay, so if you don't put a variable to catch the return value will come on your screen, and if nothing comes on your screen despite not having a variable to catch it, it means nothing was really returned. And there are plenty of examples of functions or methods which do not return anything, and we saw something right now. No talkback from the method, nothing was printed on the screen, but what it has done is it has slightly changed the object on which it was acting, or the instance li. It now has another 50.1 at the end. Remember, before index number 20, and 20 is a long way off, so it just gets added to the end. So li.insert is a method which works quietly, does not talk back. Li.count, on the other hand, does not do anything to the list li, gives you back or returns a value. Okay, now let's come to pop. As the help said, Pop removes and returns the value at position index. So if I use pop without any argument, but let me remind you once again, because it's a function and you're calling the function, you have to put the round bracket. Without that, it's not a function call. So you see, something is being printed on the screen. That means something was returned. 50.1 was returned to you. Why 50.1? Because that's the last entry of your list li. But what has happened to li as a result? Notice that the list has shrunk. This last object has been removed and returned to you. Well, it's not necessarily the last object as the help told you. That's a default, but you can always do something like this. So I'm asking li to remove and return the object at index number 2. So it returns the object at index number 2. At the same time, it has removed it from the list. So the list has become smaller. There is no string apple in the list any longer. It's 1, 2.5. Okay, there is one. The one at this position is still there. But the APPLE string that was there in index 2 earlier is no longer there. So the list has become smaller because of the pop. Pop essentially is like you're trying to pop something out of a container. So the container, after it pops out something, no longer contains the something. Fine. And there was something else at the end of the help. It said it will raise an error if the list index is out of range. Let's say I try li.pop20, and of course there is no element at index 20 here, and so it raises an index error. Python error messages are actually quite explicit and they tell you a lot about what's going on. So rather than be afraid of error messages and treat them like your enemy, you should learn to treat them like your friend. They will tell you exactly what is going wrong. Let me tell you, nobody writes perfect programs. So if they did, they'll never learn anything from them. Writing imperfect programs, making errors, looking at the error messages and learning from that is the best way to actually learn how to code. So here Python is telling you have an index error and pop index out of range. It just tells you that the index you have supplied is way too big. Right, so that's pop. Then we have remove, reverse and sort. Okay, let's look up the help once again. By now you know exactly what to do. Help list dot remove. So it says remove self comma value, remove first occurrence of value. This is very important, first occurrence, and raises value error. Of course, you have seen value error before. If we are trying to find the index of an object, if that object was not present. Here raises value error if the value is not present. Okay. If it is present, it removes it. The first occurrence, note, not all occurrences. So here, for example, if I want to remove 1, the value, not the index. If you want to remove what is at index 1, what you would use is pop. Here, what you're doing is you're removing the first occurrence of the value 1. So li.remove 1. Again, a silent worker, nothing returned to you. Notice the second one is still very much there. The first one, on the other hand, the 0th one, has been moved away, removed away from the list li. So that's what remove does. And then comes reverse. That's sort of obvious. Reverse just reverses the list in C2. It just changes the order and flips it around. So again, nothing is returned. It just quietly does something to the list. And as you can see, the list has flipped around. The last entry of the original list is now its first entry, and so on. It's actually gone back to front completely. So that's what reverse does. The critical thing to remember about reverse, and this is something you're going to use several times later, is reverse does not return a new list. It changes the list as it stands. Nothing is returned by reverse. Finally, we come to sort, and the name sort of makes it obvious. The name simply says that you expect sort to sort the contents of the list in ascending order by default. So let's just check out whether that is right. If a sort has the longest help entry among all of these, there's quite a lot of things said here. Notice here you have self comma slash. That means sort has no positional arguments. Okay. Then comes key equal to none, reverse equal to false. Okay. Now these two things, out of which key is slightly more difficult to understand, and we are going to discuss key later on when we use it. And it's actually quite useful, but we will have to learn a bit more about various Python objects before we can make it useful for us. Reverse equal to false, that's the default value. False is the default value. That means you don't reverse by default. So the thing goes in ascending. What it says at the end is the reverse flag can be set to sort in descending order. So what was ascending order now becomes a descending order. If you just use reverse equals true. Notice that reverse is obviously a Boolean argument. It takes two values, false or true. Okay. In this case, if I try sort on this list, of course li.sort, without any arguments, that means by default reverse is false, so it's going to put the whole thing in ascending order. But there's a bit of a problem here. Of course, we understand what ascending order means for 2.5 and 1 or 9.1, which one is bigger, which one is smaller, but there's a string somewhere stuck here. And exactly because of this, you have a problem. You see, less than, which is what you have to check, right? Because to put something in ascending order, you check whether things are smaller or bigger, is not supported between instances of str and float. So there's an apple, and you want to compare it with 2.5. You can't. There is no meaning to that. So this is what you're going to get, an error. By the way, older versions of Python did not give an error here. They use a convention as to whether strings are smaller than integers or not. Maybe for the old timers, most likely it went with the ASCII values involved. But the latest versions of Python simply give you an error and do not try to put things which cannot be compared in order. So in order to use sort, let us first do one thing. Let's use our newly learned remove function to remove apple from the list. So now the list has only two kinds of objects. They are all numbers, but there are integers and there are floating point numbers. However, comparing whether an integer is bigger than or smaller than a floating point number is easy, and Python can do that. So let's Now try sort. And it just does sort it. Again quietly, nothing returned. And what's li? You can check. Li simply becomes 1, 2.5, 2.5, 7, 7, 9.1, 9.1, 50.1, 50.1, 50.1. So all the largest elements, 3 of them have gone at the end. To see what reverse flag does, let's just take this list, copy it, and put it back, put li back to this value. Okay, so li now is the unsorted list that we started with. Let's try li.sort again, but this time let's use the reversed equal to. This is the keyword argument, so it has to be named. Oops, reverse is an invalid keyword argument for sort. That means my memory has not worked properly, and whenever we see something like this, there's no need really to panic. Let's go back and take a look at the help again. Aha! The name of the argument was not reversed, it's reverse. That makes sense, right? It's a verb. It says reverse the list or reverse the sorting order. So I should have called it with reverse equal to false. And now li. Okay, if I call it with reverse equal to false, there's hardly no difference. That was a bit stupid of me. Remember, false was the default value, and that is, do not reverse the order, put it in ascending order. That's exactly what it has done, what it did the last time. What I really meant to do, and that's something I'm going to demonstrate after I get list back to the unsorted one. I don't want reverse equal to false at all, because I don't need the argument reverse in that case, because that's the default value anyway. But what I wanted to do was use reverse equal to true. Now look what li has become. It has become in descending order: 50.1, 50.1, 50.1, 9.1, 9.1, 7, 7, 2.5, 2.5, 1. I did not have much to say about the key argument for sort right now, for the simple reason that to understand the key argument we'll need to learn a bit more Python first. But let me tell you a situation where the key argument would be useful. You saw a while ago we had this problem when we had a list with a float inside the list and a string at the same time. Sort complained that it does not know how to compare or put a string with a float, that is, it does not know what less than does in between the two. The key argument essentially is a way of telling Python how the comparison goes, not necessarily the standard comparison of the way one number is bigger than the other. You may want to use some other comparison, and there may be many situations where other comparisons may be useful. And key essentially tells Python what kind of rule to use to compare two elements to decide which one is bigger, which one is smaller, so that you could put them in order. We will have a lot more to say about these things later. Now, with this we come to the end of the list of all methods which list has. This was not a very long list. Other Python objects have longer list of methods than the list object. But these methods that we have learned, when combined properly, can give you very powerful ways of doing things, as we will see in later videos. But the most important lesson that I want you to learn from this one, I've said that before, but it's important enough so that it should be stressed again. What you should do is know where to look for help. If the net is handy, you can always go and ask Google about it. But even without the net, the Python documentation is good enough. You just have to learn how to ask and how to make sense of what Python answers to you. In the next video, we are going to look at another kind of object which is very, very important, which is the string. And once we have learned a bit more about lists and strings, We will come back and combine them and do some rather magical things with them, including draw crazy figures like fractals. But all that is for later. Bye for now.